Okay, now that we have gone through the equation writing part, we can go ahead and answer these key attributes for these functions. And we can answer these questions very easily because most of these key attributes are vividly and explicitly shown on the graph. So it's just a matter of, do you know how to read the graph and express the values, or express the values or answers properly. Okay. Now let's first talk about the first graph right here. Let me erase the circle. Now we will go ahead and talk about the domain and range. And in case you forgot about the meaning of domain and range, the domain is about the X and the range is about the Y. Domain is to describe all the possible X values, and the range is to describe all the possible Y values. Okay, make sure you say it out loud too, because if you don't say it out loud, your brain may not get convinced by what you are listening to. So you may want to pause the video and say it out loud again, like, oh, domain is to describe the possible X values from the graph. The range is to describe the possible Y values from the graph. Once you are able to verbalize these words or the meaning of these words that you see, like domain and range, for example, you will become much better because your brain will learn how to recognize these features or these key attributes, and then you will just be able to look at the graph and see, wow, the answers have been on the page so explicitly for the whole time. Okay, so now let's look at the domain first. Well, as you can see the graph, it's going to go left and right because you can see the arrows right here. You can see the arrows right here. So, so the domain is going to go from negative infinity all the way from the left to all the way to the right, which is infinity. So by using interval notation, we will say from negative infinity to infinity. Okay. Or you can say, you can use a set notation, which is x such that x is equal to all real numbers. Okay, so but again, we will prefer interval notation slightly because that's what we will continue to use in pre-calculus and calculus. Okay, and for range, we will say, oh yeah, so for the range, what is the range? What are the possible Y values? Well, what you can see here is that, as you can see here, is that the vertex is located at -2, 2, right here. This is the vertex, okay? And the graph would only go up and not down. So that means the Y values would be everything from 2 and up. All right, so anything that's bigger than 2, okay, those are the possible Y values. But for the values that are below 2, we will say, nope, nope, that's a no-fly zone. Okay, there will not be any valid Y values below Y equals to 2. So to express our range, we will simply say, all right, it is going from 2 all the way to infinity. We use bracket for 2 because, well, we do have 2 as a valid Y value, and then it goes all the way to infinity. And for infinity, as always, we will use parentheses to close it. Okay. If you use such notation, it will be, well, hold on, I made a mistake here. It's about Y, so not X. So Y such that Y is greater than or equal to 2. Okay, make sure you use the inequality symbol very, very carefully. Okay, and we say, okay, what about the y-intercept right here? Right now, this is going to be a very interesting one. So before we talk about the y-intercept, let's go ahead and clear the picture really quickly. Now, for the, well, let's go ahead and talk about the x-intercept because it's very easy to tell. It's not available because, or you can write none as well, since we don't have an x-intercept right here. Now, the y-intercept, it's going to be a pretty interesting one right here, because some of you may go ahead and put down 2.5. And I would say, are you sure that's 2.5? Because it doesn't look quite like a 2.5. And if you're going to guess, and we will say, no, please don't. Please do not guess if the graph, it's not cutting on the axis, or it does not show a nice clean cut on the at an integer. Please don't guess. Well, but what do we know about a y-intercept? Well, we know one thing for sure. That is the x value, it's equal to 0, right? We just need to know what's the value. Is it 2 point something? Well, what's that 2 point something? What's that something? How do we do that? Well, we can easily do that by using our, now there are two ways to do that. Actually, I'm going to give you the two ways. First, well, you have an equation, right? Then you can rely on this equation by simply saying, well, since I have the x value equal to 0, so let's go ahead and find out f of 0, which means that our x value is 0. Okay. And let me do a good notation. Since I substituted 0 into x, I'm going to use parentheses, although it doesn't really make a big difference or any difference whatsoever, but it's just a good habit. Okay, it's a good habit to have. So we say, well, that means we have an absolute value of 2 times 1/3 plus 2. Okay, now some of you might be making a mistake right here because of your work previously. Some of you might think about having a +2 and -2 as a result. We don't. Okay, we don't, because just ask yourself, what's the absolute value of 2? It's just 2. Okay, it's just 2. We don't have a plus or minus 2 because we are not trying to solve anything. Okay, it's a very simple notation. For those who might think about having a +2 and -2, chances are you're memorizing something, so that you are using your memory to do something that it's unnatural. So here's a little advice for you. Understand the notation. Do not memorize. If you tend to memorize some work, you will easily become your own victim. Okay, so that's my advice. So absolute value of 2 is just 2. So we have 2/3 plus 2, and then we have 2 2/3. So therefore, this is going to be the value for the y-intercept. Okay, the y-coordinate of the y-intercept, 2 2/3. 2 2/3. Okay, now please do not do this. Do not do this. Do not do this. Okay, these are or do not do this. Okay, do not do this. Okay, please don't. And the reason why we would say, yeah, don't do this, this, or this, because we want an accurate value. And in this case, the accurate value is to be expressed by a fraction. So 2 2/3 will be the only accepted answer here. Now, if you say, hey, Mr. Chen, can I use h/3, which is the same thing as 2 2/3? Yes, that's fine. I will take it. If you put down h/3, that's fine. But for the ease of our drawing, for the ease of our expression, I think it's better to use 2 2/3 right here, so that people can get a clear idea of what's going on. Okay, so now what about the symmetry? Now, for symmetry, we will say that the symmetry, it's where it cuts the graph into 2 halves. And one thing about the absolute value function is that it always shows a symmetry. The left side and the right side, it's going to be a reflected image over a line. And we want to know where the line is. So I'm going to use my red line to draw the line that reflects the 2 graphs right here. Okay, so that will be the line of symmetry. And this line of symmetry would have an equation of x is equal to -2. Okay, so that's what we will write down for the symmetry. X equals to -2, okay, for the symmetry. Now, some of you might make a mistake. Instead of put down x equals to -2, you might be tempted to write down y it's equal to -2. I would when I was young. The reason why I would be tempted, because we tend to associate vertical lines with the letter y, since y-axis is vertical. Okay, so in order to prevent this kind of mistake, we must clearly understand why it is called x is equal to -2. So if you find yourself having this kind of confusion, I will give you advice. So let's just think about this. If you have a point right here, well, that's actually not a good one. Let me go ahead and use a black dot. Let's just say we have a point right here. Okay. How would you actually name this coordinate pair? Name the coordinate pair of this point. And we'll say, oh yeah, it is going to be -2, comma, and -5. Okay, I think that's pretty easy. Just read the graph. And then on the other side of the line, I'm going to say, how about this point right here? How would you name the point up there? All right, so you would say, oh, it is going to be -2, comma, 4. Now we can do more examples, but one thing that you will see throughout any points on this line is that the x value would stay at -2. And this is the reason why this line is called x equals to -2, because every single point on this line would share something in common. And that is the x value is equal to -2. And that is the one feature that remains true for all the points on this red line right here. So that's how we learn that, oh, for the vertical line, it's always x equals 2. Okay, and for this one, it will be x equals to 2. Okay, so we have that. So that's pretty straightforward. Okay. And then for the one last question, it sets a minimum on interval 4 to 7. So we'll look at the interval from 4 to 7, and we say, all right, let's go ahead and look at from 4 to 7. Oops, actually, I want to use a thinner pen to draw this. So I'm going to draw a rectangle, and I'm going to say, all right, from 4 to 7 right here. Okay. So in this window from 4 to 7, what is the minimum? What is the smallest value on the graph when it is, when the x value is from 4 to 7? So that means we are only analyzing this portion of the graph. We are only analyzing this portion of the graph, not the entire graph, but just this portion of the graph. So we'll say, hey, what's the y value that's the smallest here in this window here? And we say, oh, you know what? The window that's smallest is right here. Okay, and that it's going to be 4, 4, the point, and well, since we're only expressing the y value, it's the minimum. Okay, so we simply write down 4 as the answer. That's supposed to be the y value. Okay, again, the interval, it's indicating the x value here. What's the minimum from 4 to 7 for the x value, and the y value is just that. Okay, the y value is just that. Okay, so that's how you would get it. And I do apologize for one thing, that's the graph, it's not absolutely aligned or pretty. Like for example, right here, it's supposed to cut at the corner perfectly, but sometimes computer graphics are hard to modify or to adjust. So so apologize for the imperfection of this graph. Okay, so again, these are all the key attributes that we will learn, that we will write down. So so I would say the main thing to go over here is to understand how much of these information they are already on the graph. So all you need to do is to know what they're asking, understand how to interpret the question, and then you write down the answer properly. That's really what you need. Okay, so now I'm going to quickly go over the other two. So for the second graph, the domain, it's going to be negative infinity to infinity. Okay, so what you realize is that the domain is going to be the same for all the absolute value function. And for the sake of time, I'm just going to use interval notation for the rest of the video. The range, it's going to be all the way from negative infinity to 9. Okay, now one thing to be careful here is that we always describe the interval from the smaller number to a bigger number. So your mind might be thinking about 9, but make sure that you tell yourself that we always describe the number from small number to big number. The y-intercept in this case is pretty nice. It's right here. So it's going to be 0,3. Okay, 0,3. The y-intercept, it's going to be 3,0. And well, it's supposed to have another one. Okay, supposed to have another one right here. So somewhere beyond the line. So how can you figure that part out? Now that's a really easy way to tell. And that is, well, if you can take a look at this, we'll say, hey, what's the distance over here? What's the distance? We'll say, hey, that's a distance of 9. That's a distance of 9. It's gonna be a little bit hard to read, but yeah. So the distance from the vertex to the x-intercept is a distance of 9. So that means the other x-intercept must be 9 units away from the -6, which means that the x-intercept is going to be -15,0, which is 9 units to the left of -6. Okay, 9 units to the left of -6, which is -15. Okay, that's one way to do it. The other way to do it is to, well, you have the equation, so we can set it equal to 0, and that would also be doable, but that would take you some work and some space to do the work as well. So since we don't require you to do the work, so this simple figuring out would be just as good. Okay, just as good as solving the x value by setting the f of x or the y value equal to 0. The symmetry, it's going to be x equals to -6. Okay, and the maximum on the interval -8 through 4. So I'm going to go ahead and draw the rectangle so they can see better. Okay, so x through 4, -h through 4. So what's the maximum? And we say, hey, the maximum happens at the vertex right here, and that has a value of 9. So we put down the 9 right there. Okay, we put down the 9 right there. Pretty straightforward, pretty straightforward. Okay, so for the last one, the range, for the last graph, it's going to be from -4 all the way to infinity. So bracket -4 comma infinity. The y-intercept, it's at 0 comma -4. That's very visual. Okay, and the x-intercept, it's going to be -2 comma 0 and 2 comma 0. Okay, oh, by the way, when we ask for a y-intercept and x-intercept, please make sure that you are presenting as a pair, a coordinate pair for each point, because we're asking for a point, so we need a point. We need an expression of a point. Okay, symmetry is very simple. It's x equals to 0. Alternatively, I would accept that if you write down y-axis, I would accept that as well. And for the minimum between -2 to 2, so let me go ahead and draw the window right here. So from -2 to 2, the minimum would appear at the vertex right here. So we'll say -4. Okay. So again, These key attributes are fairly easy to find out. They are shown explicitly on the graph. So that's something you can easily take hints from the graph and just put it down on the put it down into the blanks. Okay. So that's it. The next video we'll go over some graphs, or we will actually look at some equations that that are given to us, and we'll draw graphs, and we'll also try to interpret the key features.